The SCMaglev is a magnetic levitation railway system based on the principle of magnetic repulsion between the track and the cars. The Central Japan Railway Company and the company's Railway Technical Research Institute developed the system. On the 21st of April 2015, a MAN 7-car L0 series SCMaglev train reached a speed of 603 km per hour, less than a week after the same train clocked 590 km per hour, breaking the previous land speed record for rail vehicles of 581 km per hour set by a JR Central MLX01 maglev train in December 2003. Technology. The SCMaglev system uses an electrodynamic suspension system. Installed in the train's bogies are superconducting magnets, and the guideways contain two sets of metal coils. The current levitation system utilizes a series of coils wound into a figure 8 along both walls of the guideway. These coils are also cross-connected underneath the track. As the train accelerates, the magnetic fields of its superconducting magnets induce a current into these coils due to the magnetic field induction effect. If the train were centered with the coils, the electrical potential would be balanced and no currents would be induced. However, as the train runs on rubber wheels at relatively low speeds, the magnetic fields are positioned below the center of the coils, causing the electrical potential to no longer be balanced. This creates a reactive magnetic field opposing the superconducting magnet's pole, and a pole above that attracts it. Once the train reaches 150 km per hour, there is sufficient current flowing to lift the train 100 mm above the guideway. These coils also generate guiding and stabilizing forces, because they are cross-connected underneath the guideway. If the train moves off-center, currents are induced into the connections that correct its positioning. SCMaglev also utilizes a linear synchronous motor propulsion system, which powers a second set of coils in the guideway. History. Japanese National Railways began research on a linear propulsion railway system in 1962 with the goal of developing a train that could travel between Tokyo and Osaka in 1 hour. Shortly after, Brookhaven National Laboratory patented superconducting magnetic levitation technology in the United States in 1969. Junior announced development of its own superconducting maglev system. The railway made its first successful SCMaglev run on a short track at its Railway Technical Research Institute in 1972. Miyazaki Test Track. In 1977, SCMaglev testing moved to a new 7 km test track in Hyuga, Miyazaki. By 1980, the track was modified from a reverse D shape to the U shape used today. In April 1987, Junior was privatized, and Central Japan Railway Company took over SCMaglev development. In 1989, Junior Central decided to build a better testing facility with tunnels, steeper gradients, and curves. After the company moved maglev test to the new facility, the company's Railway Technical Research Institute began to allow testing of ground effect trains, an alternate technology based on aerodynamic interaction between the train and the ground, at the Miyazaki test track in 1999. Yamanashi Maglev test line. Construction of the Yamanashi Maglev test line began in 1990. The 18.4 km priority section of the line in Saruno, Yamanashi opened in 1997. MLX01 trains were tested from 1997 to fall 2011, when the facility was closed to extend the line to 42.8 km and to upgrade it to commercial specifications. Commercial use. Japan. In 2009, Japan's Ministry of Land, Infrastructure, Transport and Tourism decided that the SCMaglev system was ready for commercial operation. In 2011, the ministry gave JR Central permission to operate the SCMaglev system on the Plachuo Shinkansen linking Tokyo and Nagoya by 2027, and to Osaka by 2045. Environmental impact assessments are currently underway. USA. Since 2010, JR Central has promoted the SCMaglev system in international markets, particularly the Northeast Corridor of the United States. In 2013, Prime Minister Shinzo Abe met with U.S. President Barack Obama and offered to provide the first portion of the SCMaglev track free, a distance of approximately 40 miles. Australia. In late 2015, JR Central partnered with Mitsui and General Electric in Australia to form a joint venture named Clara to provide a commercial funding model using private investors that could build the SCMaglev, create 8 new self-sustaining inland cities linked to the high-speed connection, and contribute to the community. Vehicles. 1972 LSM 200, 1972 ML 100, 1975 ML 100A, 1977 ML 500, 1979 ML 500R, 1980 MLU 001, 1987 MLU 002, 1993 MLU 002N, 1995 MLX01, 1997 MLX01, 2002 MLX01, 2009 MLX01, 2013 L0 Series Shinkansen. Records.